All right, so for this video, we're going to talk about the types of problems that you're going to see in each section and just make sure everybody's clear on what you're expected to do. So it says in triangle IJK, the measure of angle K is 90 degrees, side KJ is 77, side IK is 36, and side JI is 85. What ratio represents the cosine of angle I? So the first thing I'm going to do is I'm just going to draw a general triangle, and we're going to make sure it's a right triangle. It doesn't have to be perfect. Now, a couple of things I want to make sure I identify. The first thing is which angle is your right angle. So we know that K is going to be my right angle because it said it was 90 degrees. You also need to identify which one is your longest side. So your longest side is 85. That's going to be your hypotenuse. So therefore we can label this one J and this one I. And again, when we're looking at this, it doesn't really matter if I put J at the top or I down here, or put I up here and J down here, as long as it's on that hypotenuse side. So the next thing I'm going to do is I'm now going to fill in the rest of my information. So it says that KJ is 77. So KJ is this side right here. So KJ, we're now going to make that 77. So we got this piece, this one, and this one. And now they want us to fill in IK. So here's IK. So IK down here is 36. Now, this is obviously not drawn to scale, but we're still looking to answer what ratio best represents the cosine of angle I. So angle I is what we're going to be looking at. So I'm going to come over here, and I'm going to highlight what angle we're looking for. So we're looking for angle I. So you're going to pretend that you are standing at angle I. And we're looking for cosine. Now cosine, if you remember, the cosine ratio is going to be adjacent over the hypotenuse. All right, so adjacent means beside. Hypotenuse is that longest diagonal side. So the side that is adjacent to angle I is going to be 36. So if we're standing right here, adjacent is 36. The hypotenuse is going to be 85. So my cosine of angle I is going to be 36 over 85. Now, let's say they ask for sine. So remember, sine is going to be opposite over the hypotenuse. So if we're standing right here, I, the side that's opposite, we're going to go across that triangle. So across the triangle is 77. So opposite of the angle I is 77, and the hypotenuse is still going to be 85. So if I were doing sine, I would say the sine of angle I is 77 over 85. So all they're asking you to do here is they're asking you to identify that ratio, that key ratio. So they asked for cosine, so that's what we gave in this problem. Now again, I did a second one with sine, and I'm actually going to do tangent. But if they ask for cosine, you're going to do adjacent over hypotenuse. If they ask for sine, you're going to do opposite over adjacent. Or if they ask for tangent, then you're going to do opposite over adjacent. All right, so again, if it were tangent, so tangent of I is my opposite side. So my opposite side is 77 over my adjacent side, which is 36. All right, so make sure you label your triangle. Just draw a general triangle, and make sure you label your right angle, and make sure you label your hypotenuse, and then fill in the rest of the information. All right, so for this particular problem, they already drew the triangle for us. They said in triangle QRS, the measure of angle S is 90 degrees. So we know S right here is our right triangle. The measure of angle Q, so the measure of angle Q is 29 degrees. Then we know the side RS is 83. And again, just to make sure we're aware, this little angle mark means angle measurement, and it has a degree mark. Find the length of S cubed. They want us to find the length of S cubed. So they've labeled it as X. They want us to find X. which is the length of SQ. And they want us to round it to the nearest foot. So how do we do that? Well, we're going to set up the trig ratio that corresponds to that piece of information. So we're never ever going to use that right triangle. We're always going to use the other given angle. So my other given angle in this problem is 29. So from 29, we have an opposite side. So this is opposite. And we have the adjacent side that we're trying to find, which is x. So opposite and adjacent, that means we're going to first identify which trig ratio to use. And if I have opposite and adjacent, that means that I'm going to be using tangent. So remember, the tangent of theta is opposite over adjacent. So the tangent of 29 degrees equals, my opposite is 83 over my adjacent x. Now you're going to have to solve this, okay? So the easiest way to solve this is to think about it like cross multiplying. So I'm going to put this over 1, and I'm going to cross multiply my top to my top, my bottom to, so my top to my bottom, and then my other bottom to my top. So this is going to be x times the tangent of 29 degrees equals 83. Now we want to solve for x here, so we're going to divide by the tangent of 29. All right, so I'm going to divide by the tangent of 29. And this is where we're going to want to use our Desmos calculator. So I'm going to flip over. And the first thing I'm going to do is I'm going to come over here to the wrench that's in the top right corner. If you can see, I'm clicking that on and off. I'm going to come there. And I'm going to make sure that at the bottom, you should see degrees and radians. It should be in degree mode, but just to be sure, make sure that the degrees is highlighted. And then from there, we're going to type in what we just were trying to figure out, which is 83 divided by the tangent of 29. So I'm going to go ahead and do my division. I'm going to do 83 in the top, and in the bottom, I'm going to go to function, and under trig, I see tangent, and then I'm going to put 29. And just to make sure I have that right, so 83 divided by the tangent of 29, and we have 149.735. So we have x is approximately 149.735. Well, the question said round to the nearest foot, or excuse me, tenth of a foot, so the nearest tenth. So if we're going to round to the nearest tenth, we're going to round to this decimal place. So that 3 is going to cause that 7 to stay as it is. So x is going to be 149.7. All right, so for the next one, we're not going to find the side of the triangle. We're now going to find the angle of the triangle. Now, whenever you are trying to find an angle, okay, so keep this in mind. Whenever you're trying to find an angle, you're always going to use the inverse trig. So the inverse trig is that value, and I'm going to show you in just a second, where if it's tangent, it has that -1 over the top. So it says that we have triangle DEF, and we know that F is the 90 degrees. We also know that FD is 75, so the length of side FD is 75, and the length of EF is 95. They want us to find the measurement of angle D. So we're going to set this up just like we set the other problem up. So we don't know the angle this time, but we're still going to start from that angle. So from that angle, we have an opposite. So my opposite side is 75, and we have an adjacent. Excuse me, the opposite side is 95 and my adjacent is 75. So the trig ratio that we are going to use is still going to be tangent, because tangent is going to be opposite over hypotenuse. So we're going to fill in our pieces of information. So the tangent of x equals my opposite, which is 95, over my adjacent, which is 75. Now, this is where I'm going to use my inverse. So right here is where I'm going to do the inverse. All right, so when I set this up, x is going to equal the tan inverse, because we're still using tangent, but we're going to do the inverse of that, of 95 over 75. So you're going to use that ratio, but now you're going to do the inverse of it. All right, so if I flip over to Desmos, I'm going to come right in here, and I should see tan inverse. So tangent inverse of 95 over 75. And I get 51.709. So we get 51.709 degrees, because we're talking about the angle. So this says round to the nearest tenth of a degree. So we're going to round the 7. So that 0 is going to make the 7 stay the same. So x is approximately 51.7 degrees for that angle D. So a couple of key things to remember for any of these problems. Make sure you identify your sides. Do I have an opposite? Do I have adjacent? Do I have hypotenuse? That will determine what trig ratio to use, because if you don't use, let me say this louder, if you do not use the correct trig ratio, you will not get the correct answer. If you use sine and you're supposed to be using tangent, it's going to give you the wrong value. So you have to make sure you're using the correct pieces. So remember cosine. So you have sine, cosine, and tangent. So for sine is going to be opposite over hypotenuse. Cosine is going to be adjacent over hypotenuse. And tangent is opposite over adjacent.